Yeah.
All right, sounds good. So let's go to our lab notebooks and start a new page, a blank page, and let's write the date and the name of the lab, which is Expand a Balloon.
Would these kind of bottles work? They're plastic.
Yes, they would. As long as it has a tiny little mouth at the top.
My little water bottle is done.
The cap size isn't like the usual ones. I think it's like a little mid. Would it still work? Would it be fine?
Yes,
Yeah, that's okay.
it looks like it works great.
All right.
Daddy, can you help me dry out my water?
Yes, those are my drawings. We will explain them in just a little
bit. I can expand that balloon. Yeah. Inside needs to be, because I'm putting all the powders in.
Yeah. I'm not going to be able to get that dry quickly.
Oh.
All right, are we finished writing in our lab notebooks?
Yeah.
If you're ready, type ready in the chat. Oh, you're good, Geraldine. All right, well, we can get started. So I've got a little water bottle here. I just took the thing off so we can see easier. And I drew a line all around it. You can see in the side camera, there's a line about a couple fingers from the bottom. So maybe like an inch from the bottom. So we want to fill that much with any kind of vinegar. I've got apple cider vinegar. And in the side camera, apple cider vinegar from Food Club, very official. You can use any kind of vinegar you want. Distilled vinegar, white distilled vinegar. What other kinds of vinegar are there? Yeah, Abby had red vinegar, but I'm pretty sure that was just because of food coloring. So fill it up to that line. It's okay if you go a little bit over. It's not an exact amount. Apple cider vinegar. Yum, yum. Okay, so next, if you have a funnel, you're gonna take that, but if you don't, like I don't, we've got a little piece of paper right here. You can use a normal size paper, but if you just kind of fold it up like this, you can see that it becomes a funnel. Just kind of roll it up so there's a little hole at the bottom, and just so it's easier to pour our baking soda in. And I've got some baking soda right here. Great value brand from Walmart, very high class and official.
I got this Ziploc bag with the tools. Do you think it's baking?
Yes, it's the Ziploc bag. I got my own Ziploc bag. And so we take the funnel and we take the balloon and attach the balloon to the end of the funnel, and you have to hold it there, it won't stay. And then you are going to pour some of your baking soda in there. Doesn't really matter how much, just like don't fill the balloon all the way, maybe about halfway. And then if it's not going down, just tap the side and the baking soda will go in. They're struggling with the funnels? It looks like I am. Oh. If any of you need help with funnels, you can always ask your parents, or if you have any questions, let me know. Just hold the funnel in one hand and then hold the balloon in the other hand. Put the bottom part of the funnel in, and then pour your baking soda. Oh no.
I'm holding the funnel with my teeth.
That's a good idea. Yeah. Sometimes I feel like I need 3 hands to do science, but I only have 2. So
How
my
much
balloon,
baking soda should we put in the balloon?
my balloon has about this much. You can put more if you want.
Okay.
I think I might put a little more in mine. About halfway, maybe a little bit less. Just take your time. And so now it's about that full. You can see that. Right below my fingers, that's all full of baking soda.
Is this too
I
much?
put a little more.
Oh, that's a good amount, Rebecca.
Okay.
Was somebody else saying something?
I put a little more than you. Is that okay?
That's okay. Yeah, that's totally okay. All right, so next, this is the fun part. First, let's think. We have baking soda and we have vinegar, and we're going to combine them together. So what do we think is going to happen? Has anybody ever combined baking soda and vinegar together?
It
It'll
doesn't
like
explode.
bubble up and like
It bubbles?
yeah.
Yeah, it's like it gets all fizzy, kind of like Pop Rocks,
reacts.
or yeah, it'll rise. Yeah. We are going to see that, and we're also going to see one other cool thing. Hint, it's the name of the lab. Expand a balloon. Does anybody have any predictions about what's going to happen to the balloon?
It's
Going to expand.
Yep, it's going to get bigger. So for this step, you take the mouth of the balloon, the open part of the balloon, and then you just put it over that, so that we have, like how my picture is, we've just got like a little deflated balloon. And then once you've done that, you can bring it up and your balloon will expand. And now I'm ready for my birthday party. Didn't have to blow up a single balloon. So yep, just flip it up, let the baking soda fall in. And look at that. Now it smells like vinegar in here.
That was so fast.
Yeah, it fills up super fast.
It's
And
so
if
cool.
I take it off, it's
really
cold.
Yeah.
Yeah, mine feels cold too. Do
My
you want to
balloon
know why
feels-
it's cold? Oh, right. Yeah, write that down in your scientific notebook. The reason why it's cold is because this reaction needs to use energy, and heat is energy, and so it's taking the energy from around it, and so it feels colder than the rest of the environment. Yeah, you guys did great. And then do we think that this balloon will float like how normal balloons float? No, we don't think it will. You can also type in chat, will this float? Yes or no?
I still have baking soda in my thing.
Still have baking soda? Oh, there's still baking soda in your balloon? Or
Yeah.
okay, did you flip it up? all the way
Yeah.
up?
Yeah.
Did it expand?
Yes.
Okay, good, good. You probably just have a little bit left over because there
Yeah.
wasn't enough. I still have a lot of vinegar left over, personally, and it smells delicious. So let's see if this will float or not. It's just sunk. It's not, it does not float. It bounces because it's a balloon, but it does not float. And that's because what we have in here is a little gas called CO2. Does anybody know anything about CO2? You can unmute and tell us, or you can just type it in chat. CO2, also known as carbon dioxide.
If you shake the water bottle, it fizzes a lot.
Yeah. Does anybody know anything about carbon dioxide?
I think you can't breathe it in.
Yeah, it's actually what you breathe out. So we breathe in oxygen, which is all around us. We all breathe in some oxygen. And then you breathe out carbon dioxide. And so you breathe out carbon dioxide, and carbon dioxide is actually heavier than the air around you. There is some carbon dioxide in the air around you, but it's heavier, and that's why it's sinking. But helium, which is found in balloons that can float, that is lighter than the air around you, so it's floating up. So why do we think that the balloon, yes, Geraldine, why do we think that the balloon got bigger?
Because it was air going into it.
Air, yeah, the carbon dioxide fills it up. It's because, like, can you think of anything that gets bigger when it goes from like a liquid to a solid? Maybe something that you drink every day?
Water?
Yeah, when you take liquid water and you freeze it, it becomes ice. And if you've ever filled up a water bottle all the way and then put it in the freezer, you'll see that it can crack the water bottle because it's expanding so much. This is actually different than how most things work. Usually, it's the most compact when it's a solid, and then it kind of loosens up a little bit when it's a liquid, and then it really loosens up and gets far apart when it's a gas. And so that's why the balloon expanded, because it went from a liquid and a solid into a gas. And so it got nice and big. So this is known as an acid-base reaction. If you've ever heard of the pH scale, pH is a fancy word for how much hydrogen is in the environment. So you can either be acidic, which is a low pH, which of 1, or you can be basic or alkaline, which is a high pH of 14. And then you can also be neutral, which is a pH of 7. Can anybody give us an example of something acidic?
Acid.
Acid? Yeah. Anything else? Oh, citric acid. Yeah, that's a fancy one. Something that's a little bit more common is lemons are acidic. Everyone is frozen for you. Oh no. Another common thing that's acidic are lemons. Or going back to citric acid, anything that's a citrus, so oranges. What about neutral? Does anybody have an example of something that is neutral? Candy has citric acid in it. Definitely. Sour candy. All right, let's go to neutral. Can we think of something neutral? I would probably say, yeah, water. Water is neutral. And then basic alkaline, that's a little less commonly known. Does anybody have an example of something basic or alkaline? Something that you use every day is basic. Something to help your teeth out. Toothpaste, yes, exactly. So toothpaste, and then if you have any like really bright white clothing, fluoride. I'm not sure about fluoride. You could look that one up. But if you have any bright white clothing, sometimes your parents will use bleach with it to brighten it up so it's a really nice, pretty shade of white. So bleach is also alkaline. And then one last thing I wanted to talk about was just soap that you use every day. Milk. I don't know about that one actually. Is milk basic? Oh, okay. Bleach, soap, and just like any like detergent or cleaning product. Cleaning products. And as Abby said, milk. So yeah, that's a kind of basic understanding of the pH scale. So what happens is baking soda is basic, and then vinegar is acidic. And so that's why it's called an acid-base reaction, because it's between an acid and a base, and then they make something neutral, which is water and carbon dioxide. Yeah, that's true, Rebecca. Definitely. But yeah, that's all I had for you. Did you guys have fun making a nice big balloon?
Yes.
You can kind of float for a second, but then it sinks back down. All right. So now we will move on to the Oobleck lab.